Hello students, good morning and welcome to another video lecture of physics. Now in last video lecture we were discussing some important concept related to entrance exam, right? We have derived the formula for magnetic field, right, for current carrying straight wire. Then based on that we have discussed about the magnetic field at the center of the square, right? In the same way we are going to discuss about the magnetic field at the center of a triangle, which was given as homework. So let us start with that. Right, suppose JEE NEET good set concept, right? This is the most important lecture for you because for upcoming tests you will find number of MCQs based on this concept, right? So suppose we want to find magnetic field at the center of a triangle. Magnetic field at the center of an equilateral triangle. We want to find magnetic field at the center of an equilateral triangle carrying current, okay? That all things you should know, or it will be given in exam, right? Find the magnetic field at the center of an equilateral triangle carrying current in same direction like this, right? So let us say this is triangle ABC, which is an equilateral triangle, and we want to find magnetic field at its centroid, you can say. So let us say this distance is y. Now if you draw a line from vertex, this angle will be 90, this will be 30, so obviously this angle is 60. In the same way you can say that this angle will also be 60 degree. This is our y, right? What is formula for a current carrying wire? For a straight current carrying wire, B wire will be equal to mu naught I over 4 pi y into sine theta 1 plus sine theta 2. This is the standard formula. If you remember this was the standard formula which we have derived. Mu naught I over 4 pi y sine theta 1 plus sine theta 2. So here from this figure you can say that theta 1 is equal to theta 2 and that is equal to 60 degree. That is fine, right? But what is y? Let us say the length of the triangle is A. You can take L if you want to. So let us take L only, right? So let us say the length of each side of the triangle. The length of each side of the triangle is L. So obviously this distance, let us say this point is O and this point is M, right? So what will be BM? So from figure you can say that, from figure, look, this is L by 2. BM is L by 2. You can see that BM will be equal to BC over 2. That is L by 2. Half of this, right? And we want Y, that is OM. So obviously tan 60 we will take. So tan 60 is opposite over adjacent. That is BM over OM. So therefore OM, which is actually equal to Y, is BM. Let me write one more step. BM over tan 60. So this is equal to, what is BM? L by 2 and tan 60 is root 3. L by 2 and tan 60 is root 3. So your answer will be L by 2 root 3. Y is L by 2 root 3. So therefore this will be equal to mu naught I over 4 pi. Y is L by 2 root 3 into sine 60 plus sine 60 degree, right? 2 2s are 4. So that is root 3 mu naught I over 2 pi L, right, into sine 60 plus sine 60. Sine 60 is root 3 by 2 plus root 3 by 2. So root 3 plus root 3 by 2 plus root 3 by 2 is 2 root 3 by 2. So 2 will get cancelled out. So this will be equal to root 3 mu naught I over 2 pi L into root 3. This is for one wire, right? This is for one wire. Now how many such wires are there? So you'll find that there are 3 wires, AB, BC and CA, right? So we are having 3 wires. So the resonant magnetic field, therefore magnetic field at center will be equal to 3 times magnetic field of each wire. Right, if you simplify this is root 3 into root 3 is 3 mu naught I over 2 pi L. So this is 3 times 3 mu naught I over 2 pi L. So 3 3s are 9 mu naught I over 2 pi L. This will be the formula for the magnetic field at the center of a triangle. You have to remember this formula directly. Suppose what is the magnetic field at the center of a ring? Then you should know B is equal to mu naught I over 2 pi R, where R is the radius. Here what is the magnetic field at the center of a triangle? Then it is 9 mu naught I over 2 pi L. Clear? In the same way you have to try for a rectangle. Look, square we have already discussed. You have to find for rectangle as well as hexagon. Say for example for hexagon, let us say this is that hexagon, right? Current is flowing in same direction. We want to find magnetic field at the center. Let us say length of each side is L. Again you will find that if you draw a normal over here, let us remove this arrow, then this will be Y, and let us say this angle is theta 1 and this angle is theta 2. What will be theta 1 and theta 2? 60 obviously, right? If you draw all these things, this total angle is 360. 1, 2, 3, 4, 5, 6, right? So total 6 are there. So 360 by 6 is 60. So in this case, theta 1 will be equal to theta 2 and that is equal to 30 degree. Right? You can easily find Y. This is L by 2. This is 30, right? This is 90, so this will be 60 and this is also 60, right? So in the same way, you have to find magnetic field like what we have done over here. In that same way, you will find magnetic field for this triangle, right? And solve that. All right. Then how many such wires are there? 1, 2, 3, 4, 5 and 6. So instead of 3 times, you will write 6 times, right? That is again your homework. Try to solve yourself, an important one. So do one thing, pause this video and copy this first. Now next is, suppose we want to find magnetic field at the center of an arc. Let us consider an arc. But before that, let me write this. Magnetic field at center of a current carrying ring. Magnetic field at the center of the current carrying ring. So you know that if this is the ring which is carrying current I, suppose this is that ring which is carrying current I in any particular direction, let us say, right? Its radius is, let us say, A. Its radius is A. Then magnetic field at point O or magnetic field at center is mu naught I over 2A. Only one ring is there, right? So n will be 1, otherwise formula is mu naught Ni upon 2A. Look, if current is flowing in anti-clockwise direction, then what will be the direction of magnetic field? So suppose if this is a wire which is carrying current in upward direction, we have already discussed this, right? Direction is most important for you. You should be able to identify the direction, or you find the direction for a given conductor, right? Carrying current. Suppose this is the wire which is carrying current in upward direction. What you have to do? You have to place the thumb in the direction of current. So this is my thumb in the direction of current, right? So, right, now if you hold this, or if you want to hold this pen, you can see that from this part my fingers are moving out towards you, and on the right hand side it is entering inside. So for a straight current carrying wire, somewhere over here we will write, for a straight current carrying wire which is carrying current in upward direction, let us say, magnetic field here will be entering inside and magnetic field here will be coming out. So what you have to remember is, suppose if current is flowing in upward direction, on the left hand side magnetic field will be coming out of the plane of the board and perpendicular to it, right? And on the right hand side magnetic field is perpendicular to the plane of the board but entering inside, right? This is the first case. Now suppose if current is flowing in downward direction, then you have to reverse this. Magnetic field on the left hand side will be perpendicular to the plane of the board but entering inside, and on the right hand side magnetic field will be perpendicular to the plane of the board but coming outside. What about a circle? Suppose we have a circle which is carrying current in anti-clockwise direction. Right, we have a circular ring which is carrying current in anti-clockwise direction. Now in this case what you have to do? You have to place your finger in the direction of current. You have to rotate your finger in the direction of current, right? Like this. So you will clearly see that thumb is pointing towards you. So if current is flowing in anti-clockwise direction, magnetic field will be perpendicular to the plane of the board but coming out here, outside, right? Perpendicular and outside, right? But if current is flowing in clockwise direction, if current is flowing in clockwise direction, in that case you will rotate your finger like this, right? So thumb will be pointing inside at point O, right? Here also at point O it is perpendicular, magnetic field is perpendicular and entering inside. It is actually something like this. If this is the current carrying ring and it is carrying current in, let us say, anti-clockwise direction, so in that case from center magnetic field will be like this. It is something like this. So it is perpendicular and coming out. This will be the direction of magnetic field, right? If it is in anti-clockwise direction like this, okay? This will be the direction of magnetic field for current carrying ring. So here also magnetic field at the center is given as B at center is equal to mu naught I upon 2A. Suppose we have an arc of particular, making particular angle, not that complete circle, but let us say instead of this complete circle we have an arc only. Let us say this is the center and this is that arc. This arc is making angle theta. Radius we are going to take A only, right? And current is flowing through it in anti-clockwise direction, there is I. What will be the magnetic field at point O due to this arc? Now look, what we should know here is, if number of turns n is 1, then theta will be equal to, angle will be 2 pi. For one complete turn, angle will be 2 pi, right? So if theta is equal to theta, if you take angle same, what will be the number of turns? Look, clearly it is not a complete turn, right? So here n will be equal to, if you make n subject, n will be equal to theta over 2 pi. Here n will be equal to theta over 2 pi. What we have done? For one turn, angle is 2 pi. So for given angle, how many number of turns are there? So that is n equal to angle over 2 pi. Clear? Now, B will be equal to mu naught Ni over 2A. So that is equal to mu naught I over 2A into what is n? Theta by 2 pi. So you can directly remember mu naught I theta over 4 pi A. So for any given arc making a particular angle, magnetic field will be mu naught I over 4 pi A. Magnetic field will be mu naught I over 4 pi A. This is the formula for magnetic field, right? So how to solve this? So if angle is 90 degree, let us say if angle is 90 degree, let me write a special case. In first case, we have an arc such that it makes an angle of 90 degree. And we want to find magnetic field at point O. It is carrying current in this direction. Angle is 90 degree. Then B will be equal to mu naught I over 4 pi A, and angle is pi by 2. So clearly you can see that pi will get cancelled out. So that is mu naught I over 4 into 2A. 4 2s are 8. You can directly write. Why I am writing this, or let me write that B is equal to mu naught I over 8A. You can remember this is the formula. B is equal to mu naught I over 8A. Why I have written this? So this is actually equal to, from this you can write mu naught I over 2A. Mu naught I over 2A is for the entire ring. So this is B of center for a ring and divide by 4. So 1/4 of the B for the center of the ring. Actually you can see that this is 1/4 of the circle, right? This is 1/4 of the circle. So magnetic field will reduce by 1/4. In the same way, if you have semicircle, then let us consider semicircle. This is that semicircle, right, of radius A, carrying current I. Now in this case, magnetic field will be, so you can see that B will be equal to mu naught I over 4 pi A into pi. Angle will be 180 degree, right? Pi. So pi will get cancelled out. So that is mu naught I upon 4A. Right. This is the formula which you can directly remember. An important formula. So this is actually mu naught I over 2A into 2. So you can say that B for semicircle will be equal to B at center by 2, half of the circle. Half of the circle. In the same way, you can easily prove that if we have an arc something like this, this is the current carrying ring. So this angle will be, look, total is 2 pi minus pi by 2, right? 2 pi minus pi by 2. This angle will be 2 pi minus pi by 2. So that is equal to 3 pi by 2. Angle here is 3 pi by 2. If this angle 90 is given, then also we have to consider this angle only, not this, because here arc is not there, right? Wire is on the other side. So angle is 3 pi by 2. So in that case, B will be equal to mu naught I over 4 pi A into 3 pi by 2. So again pi will get cancelled out. So this is 3/4 of mu naught I over 2A. So that is 3/4 of B at center, or if you just want to simplify, this is mu naught I over 8A, right? And for the entire circle, suppose if you want to find for the entire circle for this case, right? So directly you can write B will be equal to mu naught I upon 4 pi A into total angle is 2 pi. Pi will get in cancel out, 2 2s are, so again you will get mu naught I over 2A, which is similar to this, right? So how to remember? For complete circle, it is mu naught I over 2A. This is 1/4 of the circle. So 1/4 of mu naught I upon 2A. 1/4 of mu naught I over 2A. This is half of the circle. So this is half of mu naught I over 2A. This is 3/4 of the circle. So you can remember 3/4 of the mu naught I over 2A. And for complete circle, obviously it is mu naught I over 2A. This is the most important concept for your entrance exam, especially for JEE, NEET as well as GUSET. MCQs can be asked based on this concept which we are going to discuss just now after this. So do one thing, pause this video and copy this first. Make sure you understand all this topic properly. Make a proper note for this, okay? Now let us say based on this concept, an MCQ can be asked like let us say we have an electron which is moving around a nucleus in an orbit of radius, let us say radius of its circular path is 5.3 into 10 to the power minus 11 meter, and it is moving with a speed of let us say 2.1 into 10 to the power 6 meter per second. Generally, this is the rough speed and radius of an electron for an hydrogen atom, right? So it may be something like that. If in an hydrogen atom electron is moving with a speed of this in an orbit of radius this, then find the magnetic field produced at the center. We want to find magnetic field produced at the center of that atom, right? So obviously formula is quite simple. B is equal to mu naught I over 2A. B is equal to mu naught I over 2A. Problem here is that current is not given. Then how to find current? Let this be equation number 1. How you can find current? So we know that actually current I is Q by T. Here it is electron, so I am writing E by T. Current I is E by T, right? So that is equal to E. What is T? So you can say that somewhere over we will write speed is distance over time. So for a circular part it is 2 pi A over time is T. So therefore if you take this in denominator, V over 2 pi A is 1 by T. So 1 by T will be equal to V over 2 pi A. So the same question can be asked like if an electron is moving in an orbit of radius this with a speed this, then what will be the current produced by it? Then the current produced by it is given by I is equal to EV upon 2 pi A, where A is the radius of that circular path. Put this value in equation 1. Substituting value of I in equation 1. Let us put this value in equation 1. So B will be equal to mu naught over 2A into EV over 2 pi A. So this will be equal to mu naught EV over 4 pi A square. This will be the formula for magnetic field at the center of an atom, right? Mu naught EV over 4 pi A square. So therefore B will be equal to mu naught is 4 pi into 10 to the power minus 7 E, charge of electron, 1.6 into 10 to the power minus 19. Speed of electron is given as 2.1 into 10 to the power 6 meter per second over 4 pi into 5.3 into 10 to the power minus 11 whole square. So clearly 4 pi will get cancelled out. So if we use calculator over here, then 1.6 into 2.1 will be equal to 3.36, divide by 5.3 divide by 5.3 will give you 0.1196 into 10 to the power. Look, minus 7 plus 6 is minus 1. Minus 1 minus 19 is minus 20, and this is 11 into 2 is 22. Minus 22 will move up, so plus 22, and this is minus 20, so 10 to the power 2, or you can write 11.96 Tesla. This will be the magnetic field produced at the center of a center of an atom, right, for which electron is moving in an orbit of radius this with speed this. So this is how you can find, right? Let us consider one more example. Suppose we have a wire like this, or let us first discuss about this thing. Suppose we have a straight current carrying wire and we want to find magnetic field at point P, right? It is carrying current I and we want to find magnetic field at point P. How to find magnetic field for this wire at point P? It may be at whatever distance it may be. So magnetic field at point P will be equal to mu naught I over 4 pi y into sine theta 1 plus sine theta 2, right? So obviously if you select this as a current element, right, then the direction of current element is this, right, and this is R, or you can write Y because I have written Y. So clearly you can see that both are in same direction, right? So theta 1 and theta 2 will be 0. So here theta 1 is equal to theta 2, that is 0. So therefore magnetic field at point P will be 0. Sine 0 plus sine 0, that is 0 only. 0 into something will be 0. So if a point is lying along the wire, right, if point is not making angle 0 with the wire, right, point is in the direction of the current element, then in that case magnetic field will always be 0. So for this current carrying wire at distance y from the wire or current element, a point P is there, and magnetic field at this point due to this current carrying wire will always be 0, right? So in the same way, if you have a question something like this, let us say we have a current carrying wire like this. Right, this is point O and we want to find magnetic field at this point O. Current I is flowing through this. Let us say this is P, Q, R, S, T and U for this wire. So clearly you can see that point O for wire PQ, QR, ST and TU. For this wire, let us say wire 1, 2, that is, this is wire 1, wire 2, wire 4 and wire 5. So for these 4 wires, magnetic field at point O will be 0, because you can see that this is the wire and point O is here, right? Then this is the wire and point O is over here, right? So almost you can see that if you magnify this, something like this, here is the wire, point is here, so this point is lying along this wire, this point is lying along this wire also. So for these 2 wires, magnetic field will be 0, as what we have discussed. Rotate this by some angle, you will get this situation, right? This is the wire and here we have that point, right? So magnetic field will be 0. So your magnetic field will be only due to this arc. Suppose this makes an angle theta, then in this case magnetic field B will be equal to mu naught I theta over 4 pi r. Let us say in this case radius is, let me write A only because r we have taken over here. So A, mu naught I theta over 4 pi A, this will be the magnetic field. In the same way you can try for a semicircle like this. You want to find magnetic field over here due to this current carrying wire, right? One more example which you can try is, let us say something like this. Here is that point P, right? And current is flowing like this, then in this direction from here to here, right? Then in this direction, then from here again in this direction, right? Let us say this radius is A. For this second arc, radius is 2A. For this third arc, radius is 3A. And for this fourth one, radius is 4A. You want to find magnetic field. Look, definitely you are going to make some mistake in this case. Why you are going to make mistake? Because current for 1 and 3, let me give name. Let us say this is our arc 1, this arc is 3, this is 2 and this is 4, right? So clearly you can see that for this straight wire magnetic field will be 0. Magnetic field will be only due to arc. But for arc 1 and 3, current is flowing in clockwise direction, right? But for arc 2 and 4, current is in anti-clockwise direction. So magnetic field produced by 1 and 3 will be added up, and magnetic field produced by 2 and 4 will be added up, right? Magnetic field produced by 1 and 3 will be added up with magnetic field produced by 2 and 4. But magnetic field due to 1 and 2 and magnetic field due to 2 and 4 are in opposite direction. So the final will be difference of magnetic field produced by 1 and 3 and 2 and 4. that will be your final answer. So what I want, you should try this yourself, right? So if you have any confusion, definitely we will discuss, but what I want that you should try this yourself first. Clear? So these are the most important topic which we have discussed in this video lecture. One more thing which is left is actually for semi-infinite wire, magnetic field produced due to a semi-infinite wire, and I think some of you are having confusion in that for semi-infinite wire. So do one thing, pause this video and copy this or take a screenshot for this, and then we will discuss for semi-infinite wire. Now for semi-infinite wire, what will be the magnetic field produced by semi-infinite wire? Semi-infinite wire means if this is the wire, then its one end is known to us, where its another end is at infinite distance, and we want to find magnetic field at point P. Let us say this is at certain distance y. So obviously we have discussed that this angle will be pi by 2 and the another angle will be 0. Look, for finite wire, if this is the finite wire and we want to find magnetic field at point P, then this angle we have taken theta 1 and this angle we have taken as theta 2. This is the finite wire. This is for finite wire, right? And the formula was B is equal to mu naught I over 4 pi y into sine theta 1 plus sine theta 2. If you take these as alpha 1 and alpha 2, then this formula will change to mu naught I over 4 pi y cos alpha 1 plus cos alpha 2. You can check this, right? This formula will be cos alpha 1 plus cos alpha 2. That is also correct. Now if you make wire of infinite length, then in that case for infinite length, let me write over here, for infinite length, theta 1 is equal to theta 2 and that is equal to 90 degree. We have taken pi by 2, right? But suppose this is the point, right? This is the point which is known to us and this is infinite. Then theta 1 will be pi by 2 and theta 2, this angle is not there. So theta 2 will be 0 in that case, right? Theta 2 will be 0. So for semi-infinite wire, theta 1 will be equal to pi by 2 and theta 2 will be equal to 0. So in that case, magnetic field will be equal to mu naught I over 4 pi, let us say distance y only, into sine pi by 2 plus sine 0. Sine 0 is 0 only. So this is equal to mu naught I over 4 pi y into 1 plus 0 will be 1. So mu naught I over 4 pi y. This will be the formula for semi-infinite wire. Magnetic field produced due to a semi-infinite wire whose one end is known and other end is at infinite distance is B equal to mu naught I over 4 pi y. Actually you can see that it is half of the magnetic field for infinite wire. Magnetic for infinite wire is mu naught I over 2 pi y, and for semi-infinite wire it is mu naught I over 4 pi y. So it is actually half of the infinite wire, right? Now the question which was given to you was something like this. Actually right now I am not having that exact data, but something like this was there. It was something like this, right? This point was point P where we want to find magnetic field. This total distance was, I think, 2 meter. This wire was carrying current I is equal to phi I1 5 ampere. So here also I1 will be equal to 5 ampere. In this case, let us say this is I2 which is 10 ampere. So here also I2 which is 10 ampere. Clearly you can see that magnetic field at point P due to this wire and this wire will be 0. Just now only we have discussed. Magnetic field at point P due to wire, let us say 1, let us say this is 2, this is third one and this is the fourth one. So magnetic field at point P due to 1 and 2, wire 1 and 3 sorry, is 0. Due to 1 and 3 will be 0. Why? Because this point is lying along this wire, right? And for these two wire you can see that this is the case which what we have discussed, right? So this distance is 1 meter and you can directly use this formula. So for wire 2, magnetic field due to second wire will be mu naught I1 over 4 pi into y, where y is 1 meter, right? So you can easily solve. This will be equal to 4 pi into 10 to the power minus 7 into 5 over 4 pi into 1. So this will get cancelled out. So that is 5 into 10 to the power minus 7 Tesla for B2, right? Second wire. In the same way for this wire B4 will be equal to current is 10. So you will get 10 into 10 to the power minus 7 Tesla. You can check. 4 pi into 10 to the power minus 7 into I2. I2 is 10 over 4 pi into 1. So this will be B due to fourth wire. Now for this 4 wire, current is moving in upward direction. So your magnetic field will be coming out of this, right? For this, current is moving in downward direction. Look, at the beginning of this video lecture, we have discussed that if current is moving in upward direction, for a straight wire, if current is moving in upward direction, magnetic field will be coming out of the plane of the board on the left hand side. And if current is moving in downward direction, magnetic field will also be coming out of the board on the right hand side, reverse of this. So for this wire also, magnetic field at point P will be coming out. So both these magnetic field are in the same direction. Look, here only we have derived in the beginning of this video lecture actually, that if current is moving in upward direction, magnetic field here will be entering inside and here it is coming out, right? And if we have a wire which is carrying current in downward direction, then on the right hand side magnetic field will be coming out and on the left hand side it is entering inside. So this is downward direction. So at point P, we want to find magnetic field at point P, which is on the right hand side. So for right hand side it is coming out. For this wire, on the left hand side it is coming out. So both this magnetic field due to these two wires is coming out of the plane of the board and perpendicular. So the resultant magnetic field will be magnetic field due to second plus magnetic field due to fourth, and you have to add this thing, right? Quite simple, just a basic concept which you should know. Clear? So this is it for this video lecture. In next video lecture, that is on Wednesday, we are going to discuss few more important concepts related to MCQs for your upcoming test. Clear? Thank you.